This is Algebra 2, Unit 3, Lesson 2 on average rate of change. The average rate of change is really important when we model functions because we are often interested in the rate that the output is changing compared to the rate of the input. We did a lot of this in Algebra 1, so we're also going to be looking at it in Algebra 2 as well. So let's take a look at the function graphed at the right. We're going to be looking at this rate of change. So let's evaluate each of the following. Let's review some function notation. F of 0. All right, so when the input is 0, what is the output? 0 is at 1. All right, when we have f of 4, when x is 4, what's the y? 1, 2, 3, 4, 5, 6, 7. F of 4 is 7. And then f of 7, which would be right here, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And f of 13 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so remember that these are actually coordinate points. This is the point 0, 1, 4, 7, 7, 10, and 13, 15. It's just another notation that we have for this. All right, so let's look at the change in the function. In the function, which would be delta f, usually what we see on this is when we're saying change in the function delta f, we're looking at the change in the y. So technically that's really change of y over each of the following domain intervals. Okay, so let's find these by subtraction shown in the graph. All right, so we are going from here to here, from 0 to 4. Here's 0, here's 4. All right, so the change in the function would be delta f would be f of 4 minus f of 0. Well, looking at our values up here, we found f of 4 was 7, f of 0 was 1, so that's going to be 6. So your change from here to here is going to be 6. All right, we can see that from there to there. Okay, that goes up 6. All right, your change in your function, delta f, from 4 to 7. All right, so that means f of 7 minus f of 4, the change in the y. F of 7 is 10. F of 4 is 7. 10 minus 7 is 3. So that means from here to here is a change of 3. And the last interval from 7 to 13, these 2 points right here, the change in the f would be f of 13 minus f of 7. So that would be 15 minus 10, which is 5. All right, so we can see from point to point to point here, you can see that these have different rates of change at your different points. So why can't you simply compare the changes in f from part B to determine over which interval the function is changing the fastest? Well, because remember the rate of change is comparing the outputs over the inputs. So the domain intervals here aren't the same. So if I want to say this change is 6, it's not. This is 6 actually over a change of 4. All right, so from here to here, this is a change of 4. So this is delta x is equal to 4. From here to here, the change in x is going to be, delta x is going to equal 4 to 7 is changes 3. Oops. And then from here to here, your change in x is from 7 to 13, delta x is going to be 6. So remember your rate of change is delta f over delta x. So you can't just take the delta f without taking the delta x into account. So your change in output is compared to the change in input, not just the change in the output. So you can't just say this is 6, this is 3, this is 5, and take the rate of change. You also have to take into account the change in the x as well. Let's calculate the average rate of change for the function over each of the intervals and determine which interval has the greatest rate. Okay, remember the average rate of change is delta f over delta x. Or we usually see it as delta y over delta x. So this is the change in the function, is basically the change in the y. All right, so let's look from 0 to 4. Delta y over delta x, or delta f. Okay, so previously we figured out that delta y for 0 to 4 was 6. And then the change in x from 0 to 4 is a change of 4, because it's 4 minus 0. So we got this from the change in y, this is the change in x, this is of 3 over 2 when you reduce it. Okay, from 4 to 7, delta y over delta x. Well, from 4 to 7, that's an easy change. That's just a change of 3. Now, for the function value, we figured out delta f was also 3. So 3 over 3 is equal to 1. And for 7 to 13, delta y over delta x. Delta x is going to be 6, and we found previously that from 7 to 13, delta f was 5. So that's going to be 5, 6. All right, so which one has the greatest rate? Well, this is going to be number 1, because 3 over 2 is 1.5. So that has the greatest rate of change. Okay, so if we use these values as slopes and draw on the lines, let's connect the points. So let's look what happens. When I go back here, all right, I connect the points to here. Okay. And your slope is going to be 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. So this is going to be 3 over 2 is your slope. Now if you connect the next one, let me do a different color so you can see it. These two right here, okay, delta y over delta x is 1, 2, 3, 1, 2, 3, so that's 3 over 3, which is 1. So it's up 1 over 1, you can see like that. And then the last one, going from here to here, draw that a little neater, there we go. And it should be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So you can see that each one of these have different slopes. So when we draw on the slopes, the average rate of change gives a measurement of slope, and the slope is the measurement of the steepness of the line. So by connecting the points, the average rate of change is a measurement of the steepness of the line. So how fast does it rise? It's the steepness of the line. So that's what average rate of change measures. Average rate of change is a really, really important concept in mathematics because it quantifies how fast a function changes on average over a domain interval. So how fast does it change? All right, now the formula for average rate of change, remember, is delta f over delta x. So for a function over the domain interval from a to b, the function's average rate of change is calculated by delta f over delta x. Now delta f is the same thing as saying delta y over delta x. They're using f because they're using function notation here. So if we are going to change in x, would be the difference between b and a, b minus a. And then f of b minus f of a is the function at b and the function at a, the change between them, and subtract. So in order to figure out the average rate of change, we need to know what your inputs are and what outputs you get from them. Okay, so let's look at the average rate of change for the following intervals. So let's look at -2, 3 for the function f of x. So let's look at f of x. Equals 5x plus 7. Okay, so I need 2 points to work with. All right, I know that I have x's as -2 and x is 3. So what I need to know is what f of -2 is and what f of 3 is. Well, f of -2 would be 5 times -2 plus 7. And that would be -10 plus 7, which is -3. And f of 3 would be 5 times 3 plus 7, which is 15 plus 7, which is 22. Okay, so now I know that this is the point -2, -3, and this is the point 322. Okay, so delta f over delta x. Remember, delta f is the y's, so it would be 22 minus negative 3 over 3 minus negative 2. So that gives me 25 over 5, which is 5. All right, now we can also do g of x. G of x is from 2x squared plus 1. All right, so again, we need the 2 points. Negative 2 and 3 are going to be our x's. And then we need g of negative 2. 2 times negative 2 squared plus 1. Negative 2 squared is 4, times 2 is 8, plus 1 is 9. So that's 9. And g of 3 is 2 times 3 squared plus 1. So 3 squared is 9, times 2 is 18, plus 1 is 19. So there are my 2 points. So delta f over delta x would be 19 minus 9 over 3 minus negative 2. 19 minus 9 is 10. 3 minus 2 is 5. And 10 over 5 is 2. So your average rate of change is 5 over 1. So for every input of 1, you get an output of 5. For every input of 1, you get an output of 2. All right, so that's average rate of change over the interval from negative 2 to 3. So you can see for f of x, it changes for every 1 of increase, it's going to increase by 5, and every 1 of increase, it's going to increase by 2. Okay, see if you can figure out the average rate of change between the interval of 1 to 5. And we will finish up and see if you can finish up the rest of this for before class tomorrow.